Hi children, welcome to another episode of online classes in science. Today we are going to discuss about a small section from class 8, that is force. Look at this picture. So here a football player is about to take a kick. In the second picture you can see a goalkeeper catching a football so that he can save a goal. Here a boy continuously pushes the tire forward with a stick so as to increase its speed. Here you can see Indian batsman going for a cut shot. Have you ever thought how this is possible? This is possible by applying either a push or a pull. This push or pull, what we apply on an object is what is called a force. Push or pull acting on an object, we call it as force. See here, I am picking this remote. Imagine I am opening a door, I am closing a door, lifting a book. All these actions can be classified either as a push or a pull. Now, let us discuss this picture once again. In the first case, the football player kicks the football so as to start the motion of the football. In the second case, the goalkeeper applies a force to stop the football. Third case, the boy continuously pushes the tire so that the speed of the tire increases, and in the last case the batsman goes for a cut shot so as to change the direction of motion. Now look at this picture, a person standing at the back of the car. Can you say that this person is applying a force on the car? You can answer after seeing this second picture. In the second picture, the person is pushing the car. Compare these two. The first case, the man is not in contact with the car, or there is no interaction with the car by that person. Second case, that person is pushing the car. So we should understand one thing, forces will come into the picture only when two objects interact. Let us see another picture here. Two ladies are fighting each other. In fact, they are pushing each other. Last one, two ladies are actually pulling each other. There also there is interaction between the objects. Now another thing is, you can see a buffalo being pulled by three people. There also there is interaction between the objects. So let us conclude that if there exists a force, definitely there should be interaction between the objects. And this picture is quite familiar to all of you. Tug of war. Tug of war is actually a game where, maybe one and only game where a team which is moving backward wins the match. So here also there is interaction between the objects. Now another example let us consider. There is a huge block kept on the surface. A boy is trying to push the block. Can you say that this block gets displaced? Can you say that the block moves? Maybe. Sometimes if the force exerted by that person is sufficient to make the object move, definitely the object will move. Let us assume that the poor boy cannot apply that much force so that the block is not moving. Let us consider that way. Now the same block is pushed by two boys together. This time there is more probability for the block to move. Why? Because two people are exerting forces on them. So in this case we have to understand two things. Number one, when both the boys exert force on the block, the total force acting on the block will be the sum of the two forces, since they are acting in the same direction. So the conclusion is this: when two forces act on an object, the net force or the resultant force will be the sum of the forces. Let us consider another example. Here the same block is pushed by both the boys from opposite direction. So here also the block may move or may not move. If the block is not moving, what is the confirmation we are getting? What we got is this: the two forces acting on the block are equal and opposite. If it is equal, then the body will not move. If it is different and if the body is moving, the direction of motion of the body will be in the direction in which the greater force acts. To sum up, we can say that if a number of forces are acting on an object the same direction, the resultant force, we call it as net force, will be the sum of the forces, and if two forces are acting in the opposite direction, the resultant force, net force, will be the difference between the forces. One more thing we should remember always, that is, if a number of forces are acting on an object, then effect of the force on the body will be due to the net force. So, it is the net force which produces any effect on the body. Let us go further. What is the SI unit of force? SI unit of force is Newton. How does it get that unit? It is in memory of the great physicist Sir Isaac Newton. So, SI unit of force is Newton. Let us consider a block. This block is being acted upon by a force of 100 Newton from one side, that is towards my left. Another force of 80 Newton acts on the body towards the left. So, you can see that two forces which are different are acting on the same object from opposite directions. Can you tell me what is the net force acting on this object? It is nothing but 100 minus 80, which is equal to 20 Newton. Again, same block is acted upon by two forces. One is 100 Newton, another one is 75 Newton. So, what is the net force acting on it? It is 175 Newton. See the net force. Every physical quantity, not only force, any physical quantity what you measure, whether it may be force, whether it may be distance, whether it may be mass, whatever may be the physical quantity, every physical quantity has two parts. One, a numerical value, and another one, a unit. The numerical value of the physical quantity, we call it as magnitude. So, magnitude of the physical quantity is the numerical value of it. Here, net force acting is 175 Newton and the magnitude of the force is 175. Always remember one important thing, the strength of the force is measured by its magnitude. So, here two forces are acting on it, 100 Newton and 75 Newton in the same direction. Which force is having magnitude, more magnitude? It is 100 Newton. Next is, let us consider a small cushion. This is actually a small piece of cushion. I am going to apply a force on this cushion. Just listen, I am applying a force. Does the cushion move from its position? Does the cushion changes its direction? Does the cushion increases its speed, changes its speed? No. Instead, what happened to it? Instead, it changes its shape. So, we have to remember one more thing, that is force produces a change in shape. Not only change in direction, not only change in motion, not only stopping an object, it can also produce a change in the shape of an object. Here you can see this picture, a person is actually using his force so that can undergo a change in shape. So, what we have realized so far is that if you apply a force on an object, it may start the motion of an object, it may stop a moving object, it may change the speed of an object, it may change the direction of motion of an object, it may change the shape of an object, or it may cause any or all of these effects. Remember, a force may change the shape of an object, a force may start the motion of an object, a force may stop a moving object, a force may increase or decrease the speed of an object, or a force can change the direction of motion. Fine. Now, you can see a person holding a packet on his shoulder. Just like I am lifting this football, he is holding a packet on his shoulder. Here, a boy trying to lift his school bag. Third case, a person is drawing water from the well. Have you ever thought from where this force comes from? This force comes from the action of muscles in our body. See, if I am able to lift this football, I am able to lift this football because of the action of my muscles. So, the force resulting from the action of muscles, we call it as muscular force. So, muscular force is that force which is exerted by the muscles. Now, another example, here you can see a donkey carrying a load on its back. Another example, you can see a bullock cart. Animals also use the strength of their muscles for doing this work. Now, you can apply the muscular force on any object only when your body is in contact with it. Such type of forces where contact between objects are involved, we call it as contact force. So, contact forces are those forces where physical contact between objects are involved. Example, one of the examples for contact force is muscular force. Is there any other forces which are contact in nature? Let us find out. Imagine you are traveling in a motorbike. Suddenly you switched off the engine of the motorbike. What will happen to the motorbike? It will travel through a certain distance and it will finally come to a stop. You consider another example, you are rowing a boat. If you stop rowing the boat also will come to a stop after some time. Another example which is very common to all of you, maybe pedaling a bicycle. If you stop pedaling, the bicycle gradually comes to a stop. Is there any force acting on it? We don't know. Even if any force is acting on it, in which direction it is acting on it? We will give the answer for the first thing. Definitely there is a force acting on it, and that force will be in a direction opposite to the direction of motion of the object. This force we call it as friction. So, friction is a force which opposes the relative motion between two objects in contact or two surfaces in contact. So, when the cycle is coming to a stop, it is because of the friction between the tire of the bicycle and the ground, it is coming to rest. When you stop rowing a boat, it comes to a stop because of the frictional force exerted by the water there. The motorbike comes to a stop because of the frictional force between the tire as well as the road. Since frictional force also to happen, you require contact between objects. So, frictional force is another example for contact force. Let us see a video clipping here. See, upon anger, the batsman throwed his bat. The bat was in the air for some time and finally it falls to the ground, moved through a certain distance and come to a stop. How this is possible? This is possible because of friction. It is a frictional force between the bat and the ground. Because of that only the bat come to a stop. Let us move further. So far we have discussed that for the force to come into play, there must be physical contact between the objects. Is it always true? Let us verify this with a simple activity. So, here is the thermocol sheet. I am having two bar magnets with me. I am keeping one bar magnet on the thermocol sheet so that the north pole of the bar magnet points towards my right. Now, I am going to bring the second bar magnet near to the first bar magnet in such a way that north pole approaches the north pole. You can see when I am moving it towards it, I can see that the bar magnet starts repelling. Even though it is repelling like this, it is very clear that they are not in physical contact, they are not in contact at all, which means that forces can experience between objects even in the absence of a physical contact. Here, there is no physical contact between the magnets, hence this force can be called as non-contact force. Also, the force of attraction between magnets or repulsion between the magnets, we call it as magnetic force. So, magnetic force is an example for non-contact force. So, how will you define non-contact force? Non-contact forces are those forces where physical contact between objects are not involved. Example for non-contact force is magnetic force. What is magnetic force? Magnetic force is the force of attraction or repulsion between magnets. In your previous classes, you have studied that there are two poles for a bar magnet, north pole as well as south pole. Like poles repel, whereas unlike poles attract. Is the magnetic force the only force which is non-contact in nature? Let us again verify with another example. Okay, with me I have an empty refill as well as a plastic sheet. So, what I am going to do is I am going to rub this plastic sheet and the refill like this. Now, this refill, the rubbed refill, I am going to keep it over few bits of paper which is taken here. You can see that the paper bits are found attracted towards this refill. Now, this is again another example for non-contact force. So, we have seen that there is no contact force between the paper bits as well as the empty refill. What has happened here is, when this empty refill was rubbed with this plastic paper, this empty refill acquires a property called charge. Every charged object attracts an uncharged object towards it. Here, the paper bits being uncharged, it is attracted by this empty refill. Now, in fact, there exists attraction between charges, there exists repulsion between charges also. In the previous classes you have studied like charges repel whereas unlike charges attract. So, here the force of attraction between this empty refill as well as the paper bits is another example for non-contact force, and the force here is what is called electrostatic force. So, electrostatic force is the force of attraction or repulsion between charges. Is another example for non-contact force. Let us see one more example. This picture resembles Sir Isaac Newton sitting under a tree, apple tree. An apple suddenly fall onto his head. He started thinking what may be the reason for this. Finally, he got the answer that earth is attracting all the objects towards its center. The force with which earth attracts an object towards its center, we call it as gravity. Later, he explained more that it is not earth, every object in the universe attracts each other, and that force is what is called gravitational force. And gravitational force is another example for non-contact force because there is no direct contact between the objects when forces are exerting. Now, one more thing we have to remember about gravitational force. Unlike electrostatic force and magnetic force, gravitational force is always attractive. Electrostatic force and magnetic force can be attractive as well as repulsive, but gravitational force is always attractive. So, let us conclude the session by confirming to the fact that for the force to come into play between objects, there need not be physical contact between the objects. Forces can apply between objects without physical contact also. Thank you very much.